All right, continuing our discussion of conic sections that are going to be rotated. Here's a problem off of your assignment. Number 5, the equation is x squared minus 4x, y plus y squared plus 1 is equal to 0. And what I'm going to ask you guys to do is graph this for me by doing a change of variable. So again, the first two things you need to do is figure out the angle of rotation using the equation cotangent of 2 theta is equal to a minus c divided by b. So in this problem, remembering the a is the number in front of the x squared, b is the number in front of xy, c is the number in front of the y squared. So what we'd have here then, guys, is 1 minus 1 divided by negative 4. 1 minus 1 divided by negative 4 is 0. Then you go to your trig sheet and you ask yourself, where is the cotangent equal to 0? Remember, this is the point where we, let me choose my little hand. All right, we cover up the 2. We don't worry about the 2 and the 2 theta, but we just ask ourselves, where is the cotangent equal to 0? Off of our trig sheet in the quadrantal angle chart, that's going to be where the angle is equal to 90. But in our case, it's not theta is equal to 90, it's going to be 2 theta is equal to 90. All right, and then we'd have to divide both sides by 2, so the angle of rotation then is going to be 45 degrees. All right, so there's our angle of rotation, which we'll need right at the end when we graph our conic section. But we also use that to do the change of variables. So using the equations for x and y, making our substitution, what we're going to do is everywhere we see an x, then we're going to replace that with x prime cosine of 45 degrees minus y prime sine of 45 degrees. And y is going to get replaced with x prime sine of 45 degrees plus y prime cosine of 45 degrees. And I just need a little bit more room to show you the simplified version of each of those. And so let me just draw a little line across so you don't get confused. So x is then going to get replaced with, now we just use our trig sheet, the cosine of 45 is the square root of 2 over 2 with the x prime, and sine of 45 is the square root of 2 over 2 with the y prime. And then similarly for the y, oops, typo. I'll put the square root of 2 over 2 first, then the y prime. Okay, and so these then will be our change of variables. So I just need to scooch this up just the tiniest bit more because I have to see the original equation now. And going up to the original equation, wherever I see an x, I'm going to then replace it with the square root of 2 over 2 x prime minus square root of 2 over 2 y prime minus 4x y plus y squared, but y we replace with plus a 1 is equal to a 0. All right, so everywhere we saw an x, we made that replacement. Everywhere we saw y, we made that replacement. Okay, and now's the bad step or 2. We have to simplify this fella. So we have, several FOIL problems to do. We have a binomial squared, then we have 2 binomials multiplied together, then we have another binomial squared, and then I also have a distributive property that I'll have to do second. Okay, so step 1, FOIL. And so a binomial squared is going to be the first term squared. So that's going to be the square root of 2 over 2 x prime squared. So that will be 2/4 x prime squared. The first term times the second term times 2. So that's going to be minus the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime is going to be 2/4 x prime y prime. And of course those 2/4 you could immediately reduce to 1/2 if you wished right now. And then the second term squared, so a negative square root of 2 over 2 y prime times itself is going to be positive. Darn screen. There we go. Would be then positive 2/4 y primed squared. Now we have another FOIL coming up, but I also have the multiplication by 4, so I'm going to do the FOIL first, then distribute second. All right, so the firsts would give me 2/4 x prime squared. The outsides would be 2/4 x prime y prime. The insides would be negative 2/4 x prime y prime. And then the last would be negative 2/4 y primed squared. Right? Now in the next step, I'll have to use the distributive property. I'll have to distribute that 4 inside. Okay? But then I have another binomial squared, so that's going to be the first term squared. The first term times the second term times 2. And then the second term squared. And then I still have the plus 1 is equal to 0. Okay, now you need to use the distributive property, but at the same time, I'm going to reduce a bunch of these fractions. I'm going to reduce all the 2/4 to 1/2. So this will be 1/2 x prime squared minus 1/2 x prime y prime plus 1/2 y prime squared. And now distribute the 4 inside. So I'll have minus 2 x prime squared. Let's see, the 4's cancel. So minus 2 x prime y prime plus 2 x prime y prime plus 2 y prime squared. So there's the FOIL, and then I still have all these other terms. So again, reducing the 2/4 to 1/2. Okay, and now combining the like terms, putting all the x prime squared terms together. Let's see, I've got 1, 2, 3 of those fellows. So I've got 3 of those all together. So 1/2 minus 2 plus 1/2. Well, if I add the halves together first, 1/2 and 1/2 is 1. And then 1 minus 2 would leave me with negative 1 x prime squareds. Okay, then maybe put together the y prime squareds. There's one, there's another one, and there's another one. So 1/2 and 1/2 is 1, and 1 plus 2 is 3 of those. And then just well, let's get this one out of the way. Let's put all of the x prime, y prime terms together. There's quite a few of them. So 1, 2, 3, and 4 of those. And you can see that, like we've mentioned previously, all of those are going to cancel out. Negative 1/2 and positive 1/2, x prime, y prime cancel. Negative 2 and positive 2, x prime, y prime cancel. So the only thing I'm left with then is a plus 1 is equal to 0. And now that I've done the substitution and the simplifying, you can now see what shape we will get. We have 2 squared terms. One is negative and one is positive. All right? And when we have both square terms and one is negative and one is positive, we're going to have a hyperbola. So to get this in standard form then, I'm going to move the plus 1 to the other side by subtraction. And then I need to create the fractions and get a positive 1 on the right-hand side. So I'm going to divide everything by negative 1. And I'll just be able to move this up and show you my last simplifying step. On the first term, the negative 1 divided by negative 1 would cancel. But I'm going to leave the 1 underneath just to remind you. And then really there's no canceling on the next one. But I can't leave the 3 in the numerator. I have to take the reciprocal, so it's going to become a 1/3. And then negative 1 divided by negative 1 on the right-hand side is 1. And if you don't like the reciprocal of 3, the way I did it, remember you can always multiply the top and bottom of a fraction by the same thing. So if I multiply the top and bottom by 1/3, we accomplish the same thing. Okay, so now we have a standard form of a hyperbola, and now we can draw the picture. So here's our original x, y coordinate system. Our angle of rotation, remember, from the beginning of the problem was 45 degrees. And since it's positive, that means we're going to rotate the x-axis 45 degrees in a counterclockwise direction, and the y-axis in a positive 45 degree direction, which again, counterclockwise. Okay, so this then becomes the x primed axis, and this becomes the y primed axis. All right, and now we can graph our hyperbola. The number under the x's is a 1, so we take the square root. The square root of 1 is 1. So what we need to do is go in the positive direction 1, and in the negative direction 1 on the x primed axis. Okay, the value under the y's is 1/3, and when we take the square root of 1/3, it doesn't turn out perfect, but we can approximate it so we can draw ourselves a decent picture. It's just a hair less than 0.6. Just a hair less than 0.6. So I'd have to go up 0.6 on the y primed axis and, down 0.6 on the y primed axis. And then through those four marks, we can then sketch in our rectangle through which we can put our extended diagonals. And then since the x's are positive and the y's are negative, this is going to start on the right-hand side of the x primed side of the box. So we're going to have a hyperbola that opens along the x primed axis in both directions. All right, so that looks a little better. So you get the hang of it, get the hang of this. All right, so there's, that's number 5. That's number 5. So hopefully this helped you out a little bit in understanding how to work with that one. Okay, more to come. More to come. Hope you're having a good day. Talk to you soon.